Hi, great to have you. Welcome. Could you start telling us what is your team, which school you're representing, and who is here with us?
My name is Graham Wiltrout. I'm the team lead for NERFS, or the National Early Response Firefighting System. We're one of the teams from Oregon Tech competing in Invent Oregon, and we're from the Klamath Falls campus.
Hi, I'm Marcus Delmarter. I'm pursuing a mechanical engineering major here at Oregon Tech.
My name is Sydney Beers, and I'm also pursuing a mechanical engineering degree.
I'm Toby Russin, and I'm also pursuing a mechanical engineering degree.
Excellent. Welcome. Could you tell us what is NERFS, what it stands for, what are you working on for InventOR?
NERFS stands for National Early Response Firefighting System, and what it is an automated wildland firefighting system in the form of a bunch of different stations. We're going to put these all over the woods in Oregon so that we can get fire retardant onto flames within 90 seconds of wildfires being spotted.
Excellent. So let me see if I understood correctly. So you are planning to deploy this fire suppression system to fight wildfires. How you guys come up with that idea?
Last year, I was just finishing up a big project, and it was beginning to be the start of summer. And I just sat down with my family around the dinner table, and we started talking about wildfires. And we started talking about what's being done. We know a lot of people who are firefighters. We know people who work as mechanics, firefighting helicopters. We know fire chiefs. And we started discussing everything that we've learned. We started brainstorming new ideas, and we got through a bunch of different iterations. After that dinner, I went down to my room and I started writing down what I thought were all the good ideas. After that, I started talking to every single firefighter I could get my hands on. I talked to fire chiefs, smoke jumpers, hot shots, dispatchers, anyone who would talk to me. And we eventually refined it to the idea that we're pursuing.
That's very impressive. Just the fact that you went through the validation from idea to talk to the actual people that are dealing with the wildfires. Can each one of you speak about what are you in charge on the project? What are you overseeing?
In the beginning, I was doing everything because it was a solo project. Now that I have 10 team members working with me, we have each transitioned into more specialty roles. I'm handling a lot more of the project management business side of things, looking at pursuing funding opportunities, as well as making sure that we get all of our accounting and paperwork done to hit all of our goals.
Great. How about everybody else?
The part I'm working on is our full-scale prototype. It'll be a 60 millimeter mortar where we won't be able to actually use it for the competition, but we are working to do a prototype just specifically for the competition. So I'm working on designing that, 3D modeling, doing engineering calculations behind that to make sure that if we do get funding from Invent Oregon, that we're able to build a full-scale prototype and that it will be able to work for what we need.
I'm helping Marcus with the full-scale prototype. That's basically what I'm doing right now.
I'm currently working on the smaller scale software prototype. So currently we just have a small 3D printed version, basically using small stepper motors to prove that the software will work before we go to the bigger full-scale version.
So it's different components for your prototype. Definitely the physical components, the software to be able to guide the device. So Sydney and Marcus, talk more about the math and the nuances of actually launching something that will explode. What are the things that you're concerned about and how you're solving those problems?
So for one of the problems that we're facing is being able to control where exactly the fire retardant will be deployed from the mortar round. Traditional rounds use a time delay system or an impact system, but in order to get the maximum coverage that we need for the rounds, we actually have to deploy the fire retardant midair. And that's going to vary depending on every single scenario that we're going to encounter. So we're going to be using a GPS sensor inside of the round to activate the plunger, which pushes out the fire retardant through our nozzles. So if there's a situation where a fire starts in a tree from maybe a lightning strike, and we want to get up into the height where the tree is at in order to maximize our coverage up there, then we won't be able to let it expel the fire retardant on impact. So using the GPS sensor, we can target a certain height above the tree line or that specific tree where it's at to expel the fire retardant to be the most effective for what we need.
So Sydney, I'm sure there's very complex math, a lot of testing. What do you think you find more challenging or this exciting for you about this project?
It's just really exciting to see what I can do with my degree as I'm just a freshman here, so I'm really relying on Marcus to help and guide that process and just doing anything I can.
So the software part, right? So what are the challenges you're envisioning? While the part of the team is developing the physical component of the NERFS, what about the software? What are the challenges you're seeing or problems you try to solve?
So I'm not specifically in the software per se. I'm just mostly doing the physical model for the software. The other members of our team are in software, and that's their focus. At least the challenge for the physical software prototype is figuring out a mechanism to fire our miniature Nerf gun, which is what we're using to fire the round, essentially. So that's really been the biggest challenge so far, but overall it hasn't been too terribly difficult to design.
For the people who aren't here with us are the software engineering students, and they've really spearheaded their whole software using their expertise in projects that they've done on their own. And they've got almost all of our code written that we need to do, and having a big group of software engineers, they're able to rely on each other and use their strengths and weaknesses to help further the team's development for the software.
They're proving to be a really effective development team.
It's impressive that you have multidisciplinary members of the team with different backgrounds, and you have been able to broken down between software development, the physical development of the prototype, and the R&D portion, be able to 3D print and do some modeling. How do you all come together? How do you find each other at a school like Oregon Tech?
This team is pretty much comprised of people that I ran into in the beginning of my education here. I've known Sydney for a long time. We went to middle school together, and then I also know one of our other mechanical engineers, Fletcher Stoltz. He's been a longtime friend of mine and my brother's. Toby I met in a public speaking class at the beginning of the year. I ran into Marcus on our orientation day. Some of our software engineers, I just had a class with them before I switched degrees. So it's just going around and finding the people that I think would be a great addition to the team and just trying to build out a project group comprised of people who I think are smarter than me.
I think this really speaks volume about our project as well, because we can gather so many people who are excited to work on this project that's really going to make an impact in our communities, because everyone's an Oregonian and we all have felt the effects of wildfires around here, and everyone wants to jump in and help and use their expertise for good.
So you started this journey with Catalyzed Climate at Oregon Tech, the competition. How do you envision the impact of bringing NERFS to commercialization and being able to provide it to wildfires? What do you envision the impact that you will have in battling and preserving our environment?
The primary impact that I hope to have is regaining control over our forests, because some fire is good, some fire is necessary, but the fact of the matter is that our forests have gone insufficiently managed for long enough that those natural fires that are good for the environment just aren't happening anymore. Pretty much every big fire gets out of hand and just obliterates ecosystem. It displaces animals, destroys watersheds, burns people, and burns property. So regaining control over that so that we can get back and have those controlled burns and start relaying that foundation for a healthy environment is the impact that I hope to have. On the economic side of things, there's a $350 billion economic burden created by wildfires every year. And I hope to mitigate some of that as well while creating jobs. We're going to need a lot of manufacturing experts, and we're going to need a lot of people to go out and install these. So hopefully we can eliminate a lot of that economic burden while creating opportunities for a lot of people.
What insights have you learned so far going through Catalyzed Climate and now through InventOR? What are the things you have learned to help you in this journey as an innovator, inventor, and entrepreneur? What are the key takeaways you have learned so far?
For me, the first thing that comes to mind is something that I bring up a lot, and that's that generally the government frowns upon students launching ordnance through civilian airspace, which it is a funny statement to make on the surface. But there's a lot of nuance there with regulations and different processes to go about testing the system. Through researching that and analyzing our actual path to commercialization, I think I've learned a lot about how not only how businesses work, but how businesses work with the government. I think that's one of the best things that I've learned so far.
Some of the most valuable things that I've learned from InventOR is definitely the prototyping phase and how to turn that actually into working towards getting a patent, like a design patent or a utility patent. As someone who's always been tinkering, trying to invent things since I was a little kid, I never really knew how to go about that. And then through InventOR, I've learned a lot of valuable resources, as well as learning how to develop a solid business plan if for some reason ever wanted to take one of those inventions to market.
For me, it's really nice to be able to apply some of the stuff that I've learned, dive into the engineering and learning about how businesses work and all the steps that are required to get a business going. It's really nice.
Yeah, adding on, for me, I've always focused on the engineering side of stuff, of creating something cool, but then through InventOR, learn how to take that and get a prototype and then how to sell it, or the business side of stuff.
Thank you. And What do you envision to be able to achieve with NERFS? Let's say you figure out regulatory compliance, you go through InventOR. What will be the next steps for NERFS beyond InventOR?
After Invent Oregon, our next steps are probably going to be getting down and proving each system that we've created. Because for the rounds to work, we need to disperse a certain amount of fire retardant with a certain amount of effectiveness. So our next steps are going to be actually prototyping metal fireable rounds that we can start testing, and then working on getting that actual mortar tower built and getting in contact with the military contacts that we've made so we can go to actual testing ranges. So our next steps are probably going to be making sure the system that we've built so far will actually be an effective solution before we move forward with commercialization.
Is anything new that you have learned about yourselves by participating in the competition?
It's a lot easier to work on something when you're surrounded by people who are excited to work on the same thing that you're working on.
As we talked about in our boot camp, being able to see yourself as an inventor, I think that was a very valuable experience for me. So that way I can step back and think, wow, I really can see myself as an inventor, not just somebody who likes to tinker with things.
Yeah, for me, I found it's just a lot easier to work on a project that you're passionate about. Because I've had lots of events canceled because of smoke. So working on something that'll prevent that definitely helps.
Yeah, I definitely agree with that. I've also learned that actually enjoy the business side of inventions like this. It's never something that I've really been interested in, but after pursuing this project, I've learned that it's some interesting stuff.
All right, thank you. If you were to have a message for the folks watching the video, what would you tell them about NERFS and what to expect?
If I could give one person or give every person one thing to take away, it would be to look for opportunities to support not only our project, but other firefighting initiatives. Because there is a lot of innovation happening in the firefighting space, but a lot of it is not terribly well funded. So if you have an opportunity to donate to a cause that you care about, you should do it, especially if it's firefighting.